So thanks everyone for coming. My name is David Taylor. I'm a product manager here at Snowflake working on Cortex.
Hi everyone, I'm Bindu Pucha, also working on Cortex.
And today we're going to do a very quick flyby of using RAG in Snowflake with our new features, including one called Cortex Search, which we're very excited to share. So just for some context on what is Cortex, basically Cortex is Snowflake's suite of AI products. At the base of this, you have your models, and this is a very important part of the suite. So Snowflake has partner models, we have open source models, and we actually have models that we've trained ourselves. And these are things for general completion, embeddings, as well as task-specific models. So we have a model garden approach where we aim to offer the latest and greatest models at the best price performance points for all of our customers. We believe that for your use case, you should be able to pick the model that works the best and is the cheapest. So we provide a suite of these at the base layer here. And then, of course, the use cases that we hear the most about are chat use cases, which you've heard a lot about today. Today, we're going to focus on the unstructured side, specifically with search and retrieval. But there's also a structured use case, so talking to my structured data in tables and views that lives in Snowflake today. So Cortex Analyst is the product for structured data. Cortex Search is the product for talking to your documents. Unstructured data, this is where we're putting a lot of investment here at Snowflake, and we're really excited to show this off this year. All of these things are available in Snowflake via API, as well as Studio, which is a UI. And I want to iterate just how important this is. AI is a very developer-forward piece of technology. And what we want is UI so that people without technical experience can use AI in the enterprise in a safe way. And so the UI in Studio is very important for that. That said, we also offer APIs for all of the products that we're going to talk about today so that you can embed these in your applications if you'd like. So there's kind of a spectrum of using AI in your enterprise when it comes to customizing things. On the least customized side of things, you have simple prompt engineering. And this is our LLM functions product that you can use for this. So this is just providing the model with context and your data, and then it returns results, and you can do this in a kind of a batch fashion. Today we're going to focus on retrieval augmented generation, RAG, and so we're going to focus on this and talk about Snowflake's approach to it. And then at the far end of the spectrum, there's fine-tuning. This is a product available in Cortex today, as well as training an entire model from scratch. Those will be out of scope for the next few minutes here. So without further ado, we'll hand it over to Bindu, who's going to explain a little bit about RAG, as well as Snowflake's approach to it.
Thank you, David. Again, RAG needs no introduction, so I'll do a quick recap of what we mean by retrieval augmented generation. So let's consider an example. Let's say you're building a chat application for a collection of your enterprise documents. And what we have here is a user coming to this application with a question. And what you'd like to return is a succinct answer, but based on the documents that you have curated for this. So the first step here is retrieve. We would like to retrieve the documents that are closest or most relevant to the query that the user has asked. We will then augment the prompt to the LLM with this up-to-date context, so the LLM can use that. And then finally, we would like to generate an answer from the LLM. And this answer will be an informed answer based on this contextualized prompt. This is the RAG pipeline, retrieve, augment, generate. There's another advantage of this pipeline. LLMs are prone to hallucinations. And by giving them the data from your documents and collection of documents, we can make sure that the generated answer is truly grounded. So the first and a key step in this process, as you see, is retrieval. And Cortex Search is the product in Cortex AI that offers the retrieval functionality. Yeah, so Cortex Search is our fully managed hybrid retrieval solution, part of Cortex AI. So going back to our example, given a user query, what we have is state-of-the-art retrieval techniques that can then give you an ordered set of results. And these results are ordered based on their relevance to the user query. The secret sauce behind Cortex Search is the hybrid retrieval. And let's take a closer look at what we mean by that. So in hybrid retrieval, behind the scenes, there are several key parts to this. So first is retrieval, of course, and we make use of two state-of-the-art techniques, semantic search as well as keyword search. In semantic search, what we do is we embed both your query and all your documents into an n-dimensional embedding space. And then to retrieve closest to your query, we do a nearest neighbor search. And that'll give you a set of documents relevant to the query. In addition, we also do an IR-based keyword search. We extract keywords from your query and maybe variants of those keywords and look for documents that contain them. And this is your retrieval set. We combine retrieve sets from both these techniques and pass it through a re-ranker. The re-ranker rescores each of these documents based on the query once again. And finally, we combine all these three pieces of information to give you the ranked list. So the hybrid part is it's not just vectors, it's not just keyword. We combine the best in class in both cases. For keyword, we built on the state-of-the-art techniques from web search techniques from Neva. And for keyword, for the semantic vector search, in fact, we had recently announced a family of models called Arctic Embed. These are world's best, but also practical embedding models, and that's what powers Cortex search behind the scenes. But to drive home the point of hybrid retrieval, we did some benchmarks. We measured hybrid retrieval performance, both on industry standard benchmarks, as well as some proprietary RAG workloads we had internally. And as this graph illustrates, Cortex search can effectively combine both keyword and vector retrieval techniques to get the best of the both and outperform these techniques in if deployed standalone. So the key message that I want you guys to take away is that what you want powering your RAG applications is not just a vector database or an IR system, but a hybrid retrieval system that can combine both of them. And then Cortex Search is that hybrid retrieval system, part of Cortex AI. Cortex Search can be deployed out of the box, combines all these techniques. You don't have to think about individual systems or the embedding model or re-ranker models behind them. We'll see Cortex Search live in action in just a bit.
Okay, so for the purposes of time, I just want to hit a little bit on the user surface. So everything that Bindu just mentioned, it's available in a single line of code, and that's the power here. So Cortex Search, you can define in Snowflake like any other object that lives in a schema. So you create the service, you tell it which column you want to search on, you tell it which columns you want to filter on, and you define the data that is going to be indexed in the system that Bindu just highlighted with a SQL query. So the idea is that this should be very familiar if you're a Snowflake user, and if not, it's just about as simple as it gets. You're basically setting up a world-class enterprise-grade retrieval system with a single line of SQL, and this also exists via our other surfaces, including the UI. So when you do that, all the indices are built on the back end and exposed via a simple API that you could query either via REST. We also have Python APIs. These sorts of things are kind of why this product is differentiated, right? There's a lot of different approaches to RAG today where you could stitch together many different systems for all the different components that you saw in the diagram before. But the user surface here is very important because we believe that simplification of building actual enterprise-grade experiences with retrieval is what's important. So here's the UI. This is basically a way to set up LLMs and get chatting with them in Snowsight, which is the Snowflake UI. Very quickly. Again, not even a line of code required here, and you can chat with your data. So we have a concept of attaching a Cortex search service to this chat playground so that you can go in, reference the documents that you stored in the Cortex search service, and then get up and running with a simple POC. We'll then give you the code, the API, so that you can go and take these into your application and productionize them. So what we're going to do here is create a chatbot using a Cortex search service from the UI, and then we'll show quickly chatting with it. And then we'll kind of highlight why Cortex search is important in the back end. So for the purposes of this demo, we're going to find PDFs that live in a stage in my Snowflake account. For the purposes of this demo, like I said, we're going to use a small number of PDFs. So what we're going to go from here is from PDFs all the way to chatbot. Because we only have a few minutes here, I want to go through just a small number of documents. And then we'll switch over to a service that's built on hundreds of documents. The domain here is Snowflake IT. So we have all this information about enterprise applications, downloading software, booking travel, etc. Just to kind of set the stage. In this small corpus, we have information about setting up mobile devices, and we'll go ahead and create a service from these. So while this is creating, I want to explain a little bit about what's going on behind the scenes. So we're taking those PDFs, we're representing them in text form with a PDF to text type function. And then behind the scenes, we're also chunking up the results of the output into chunks that are then ingested into a Cortex search service. So that was created in just a few moments. This is pretty easy to do. We can open up the playground and start chatting with the service. And so we can ask it simple questions like how to set up Slack on my phone. So the response is streaming back. In the backend, Cortex Search is providing the context to the model that's writing the response here. So it's providing the answer. It's also citing its answer, which is very important. It'll tell you the document it came from, as well as the passage in the document that it retrieved. And remember, these are just PDFs a few minutes ago. So everything was parsed into text form and then provided to the model here. So now we can ask it something a little more challenging that it shouldn't know. How to set up Instagram on my phone. It doesn't know the answer to that question, and that's a good thing because it actually doesn't. And what we don't want is the model to hallucinate an answer to us. So what's going on behind the scenes is it is abstaining from answering any information or any questions that it got for which it didn't find relevant documents in the Cortex search service. So like I said, we have this much larger corpus that we pre-built before this demo, and I'm going to switch over to that so we can kind of show the scale portion of this. So with this larger service, we can ask it something like how to book travel to Snowflake Summit. So it's gone through that list of hundreds of documents with thousands of pages, and it's found the answer to my question. It's telling me, how to go through our trip planning service, how to actually go through the flow, search for flights, etc. And the thing that I want to highlight here that's very important is it's referenced multiple documents. So the first document it looked at is telling me how to book travel. The second document that I found is the document that contains the expense codes for booking travel that you need to plug into that process. So this is multi-hop reasoning, and this is something that's really hard to do actually, and something that I think is quite valuable for RAG systems. So it cited both answers here. Let's see. We can also try even more. We do have time. Something along the lines of where is the IT help desk in San Mateo? The Snowflake office in which I work. Okay, so the San Mateo Ice Bar is located on the second floor of the South Tower, right next to IT. That is true. I should probably go visit them after this, given today's technical difficulties. So we have this question, and then we can ask something like, what are its hours? So it tells me that the Ice Bar is open from 8 a.m. to 5 p.m. The thing we want to show off here is in this question, we didn't actually reference the IT help desk at all. It used the chat history to answer the question based on the context from above. And this is called multi-turn reasoning. So there's a lot of different tricks like this that you can go through when you're building these chat applications. Cortex Search is the retrieval part and make sure that it's retrieving the right information. And then on the orchestration side, behind the scenes here, we've done a lot of work to make sure that this stuff is enterprise grade. And the thesis here is it's quite easy to get a V1 up and running. You have a vector database, you have your orchestration, that's quite simple. But to actually get an enterprise grade version up is quite hard, and there's a lot of work to do there. And this is where we're investing a lot of our efforts. So this demo kind of shows off things like multi-hop, multi-turn that goes into that, abstaining as well. But there's a lot more we are doing, and we're excited to kind of bring through this UI as well as APIs.
Hi, so I have a question about the ingestion, like where you demonstrated the PDF being selected and the system behind the scene is extracting information, creating chunks, converting into embeddings and actually storing it, right? This all is happening. What control do you give or plan to give to users so that they can decide the chunking strategy, because that decides the quality of the output, right? And the extraction itself, like the PDFs could have very complex table structures inside it, right? Call it like 2-dimensional, 3-dimensional or beyond. It could have images as well, right? What tooling or what capabilities you're thinking to build so that users can actually take these POCs or MVPs as a production system sooner.
Yeah. So that's a great point. In the demo, you saw there was a table in one of these responses that was extracted. This is one of those items that's hard to get right. The function that's using behind the scenes is a parse document function that we're bringing to preview soon that does layout-aware PDF extraction with things like tables, diagrams, etc., and puts them in a text representation that can be embedded and then referenced by the model. There's also a chunking function using behind the scenes that will also expose to you. So all of these pieces, they're wrapped together in the UI here, but we'll give you the APIs directly if you want to tweak them and play with your own sort of pipeline. But the point is, there's an ensemble of models behind the scenes here that are doing those hard to get right things like table extraction.
Hey, could you maybe talk about what's happening behind the scene during the retrieval part, right? So apart from semantic search, are you also understanding the user intent, breaking it down into multiple questions if the use case demands it, sort of creating multiple search queries, decomposing them, and combining them? So are those advanced retrieval things, as well as things like re-ranking? I think I saw a mention of that.
Right.
What happens there? Curious to know.
We do have a collection of those techniques. So for the chat case, we do look at query. We classify the query intent. We try to understand if it's a multi-hop kind of query, and if we need multiple retrieval steps, chat history. We would like to understand if the thread has changed in the chat history or is it a continuation of the original chat. Prune the history accordingly. So a collection of these techniques on the orchestration side before we hit retrieval. And on the retrieval side, again, we do look at query rewrite. And that's why when I said in the keyword-based approach, it's not just keywords, but variants of keywords that we look for. Again, re-ranker, we are looking at how many to retrieve to get good recall performance, how many to rank so that our NDCG scores are good. So we are looking at a collection of these things yeah.
All right, good to go. Thank you all for coming.
Thank you.